Hello guys, welcome to the channel, and today I have a spicy integral to give a go. So let's just dive straight into it. Cool, so here's the integral, and I prepared a hint for it as well. So I'm just going to pause for a moment if you don't want the hint. Cool, so the hint I prepared to get started with is difference to two squares. Cool, so diving into the integral. So here's the integral, and I think the first thing to recognize is that we have these surds and these surds on the denominator, so it's really quite awkward to work with. So we definitely need to do some simplifying or rearranging. So good starting point, or I just like to write these surds as just powers to the half. And then utilizing difference to two squares. So a plus b times a minus b is a squared minus b squared. And so if we say a is equal to 3x plus 4 to the half and b is 2x plus 1 to the half, we can then multiply the denominator and numerator by a minus b, so that we're multiplying by 1 so it doesn't change the value. And we'll get here. And this half and a half times 2 is just 1, so this will cancel out. And then we get here, and we can reduce this denominator just like so. Cool, so we've clearly made some progress now because we don't have, because we've rationalized the denominator, but we still clearly have some work to do. Cool, so from here, the way I'm approaching it is to split it up into two integrals and go from there. But I will just say that there's a bonus trick, which is not necessary for this integral, but if you use this substitution, you'll get here. And what's quite nice about that is that you have symmetry with your constants for the surds, which can be quite useful. It's not useful in this integral, but stay tuned because there will be an integral coming out where this symmetry is handy. But that's a very nice trick to spot, but not necessary. But instead, I'm just going to split it up and say let I equal the first chunk here, 3x plus 4 to the half over x plus 3 dx, and let j equal this chunk here, and then use these substitutions instead to work through, and just reminding myself that the answer for the integral would just be I minus j, just like so. Cool, so starting off with I and using the substitution as mentioned, and whenever we have a new variable, we should chuck a box around it. If we differentiate both sides, we get 2u du is equal to 3 dx, and then if we make dx a subject, we get 2u over 3 du is equal to dx, and then also just saying u squared minus 4 is equal to 3x and making x a subject so that we can apply our substitution easier. Cool, and then applying the substitution, since we know u squared is equal to 3x plus 4, so we have u squared to the half, and then subbing out dx for 2u over 3 du, just like so, and then subbing out x for u squared minus 4 over 3 plus 3. And then we can multiply this 3 out, so that this will cancel out with this 3, and 3 times 3 here is 9, so we should get here. And also u squared to the half is just u. And then we can take this 2 out and write this as u squared, because we have u times u here, over u squared plus 5, because u squared minus 4 plus 9 is just u squared plus 5 du. And then from here, we can add 0 creatively. So if we do u squared plus 5 minus 5 all over u squared plus 5, we'll get here. And from here, it's a standard integral. So if we just integrate with polynomials and with inverse trig, we get here, and then just remembering our substitution and making u the subject, we would then produce that result. And let's chuck and there you go. So we now know that I is equal to this contents here, and we can chuck a purple box around it because that is part of the solution. Now focusing on j, using the same premise of setting a variable to the numerator, and then chuck a new box around it, v squared is equal to 2x plus 1. If we differentiate, we get 2v dv is equal to 2 dx. And I'm going to do something funny. I'm going to write 2v over 2 dv is equal to dx, just for a little saving of working out. You'll see why. And then just again, same thing, making x a subject. So v squared minus 1 all over 2 is equal to x. And then if we substitute, this is all very similar to what we did before, just with slightly different numbers. We end up with v squared to the half over v squared minus 1 over 2 plus 3, 2v over 2 dv. And now we can multiply this 2 out. So that's why I left it as 2v over 2 to get here. And then we can take this 2 out and we can simplify as we did before. And what we end up actually with after applying the substitution is exactly what I looked like after applying the substitution. So due to this symmetry, we already know that j is going to equal to 2 square brackets v minus root 5 arctan v over root 5. The only difference with J is that we have a different substitution. So making V the subject, we can then sub that in just like so. And we can chuck a purple box around it because it's another part of our solution. Perfect. So now we've made it here. Now we're looking for what I minus J is, and we've defined I, we've defined J. So it's just a matter of writing that down, and then we can carefully integrate. We can carefully write it all with one square bracket, and there you go. That's the answer. So let's chuck a green box around it, and there you go. That's a real tricky integral to enjoy. So I hope you enjoy it, and I look forward to seeing you guys next time.